Hello, it's Elixir Code Girl. Welcome to the fourth series of running code concurrently in Elixir. So on today's series, we're going to look at Task.await and the Task.yield, and we're going to look at the similarities between them and also the differences between them. So welcome. Okay, so the Task.await versus the Task.yield. So they both are useful when it comes to retrieving a result from a task. And if you look at them, so let's start with the task.await. It takes in a task and a timeout and returns to you any term. So this term can be there, depends on the result of the task being processed. For the task.yield, it takes in a task struct as well, and also takes in a timeout. And it returns for you a tuple of an atom, okay, and a term. So the term also here is the result of the task being processed, or it can also return for you a tuple of an atom exit and a term. So this is the term here represents the reason of the exit. Also, it can return you nil if there's no result. So they both handle a process timeout, and this process timeout is very important because it ensures that the process don't get stuck while waiting for a result forever. So you don't want your task to run forever, just trying to wait for that endless loop that will never return a result. So the default timeout that applies in both is 5,000 millisecond or 5 seconds. So let's look at how the task.await and the task.yield work. Even though we tried this in our previous series when we were looking at the task.async, because when running task.async, we had to call the task.await or the task.yield to retrieve result from it. So it will be a similar thing here as well. So I'll go to my code editor, start my interactive shell. Okay, so let's start a simple task. I'll define a variable for it. So I will define a task.async to run our task asynchronously. So I'll do a simple addition here, or computation. So here we have created our task. So it's running asynchronously. Now let's retrieve that result. So I'm going to use the task.await first. So here you can see we have our result back. Then let's create another task. So I'll just pick this again. Maybe change the computation here. I want to demonstrate how to use the task.yield. So then we call the task.yield and give it our task. So you can see the difference. So this returns the result that you're computing. This has to return a tuple of an atom, okay, and the result of what you're computing. Okay, so now let's look at the differences between the task.await versus the task.yield. So I'll go to my next slide. So the first one is that it's for the task.await, it's possible to disable timeout by passing the infinity as the timeout, the atom infinity, but with the task.yield, it's not possible to disable timeout. So what do I mean? So in the previous slide, I said that they both have a timeout, and the default timeout is 5 seconds. So with the Task.await and with the Task.yield, you can play along with this timeout. You can change the timeout, either reduce it or increase it. But with the Task.await, you can also disable it. But with the Task.yield, you cannot disable it. So let's see how that works. So I'll just clear this. Now we're going to use our code example of the send message. The first thing I want to do here is have our send message delay for some milliseconds. So here I increase the time to 30 seconds. Yeah, to 30 seconds. So with this, we want to demonstrate the timeout part. So we want to demonstrate that how we can disable and how and how Task.yield you cannot disable because it does not take the infinity. So with this, I want to first start by creating our task. But before this, let me alias. Okay, so remember that 30 seconds has surpassed the 5 seconds that it's the default timeout for the Task.yield and the Task.await. So we don't expect a result back while trying to retrieve this result because of the delay. So if I say, let me define the task. Task data sync. And I want to call the send message. That send message. Give it a random number. And that. So we have our task running. What happens when I call the task.await and give it the task? So our send message is delaying for 30 seconds. That means our task will be completed after the 30 seconds. So the task.await has a default timeout of 5 seconds as mentioned earlier. So we cannot retrieve that result. So what do? We can disable this. We can disable the timeout here, the Task.await timeout, so that we get the result back after it's finished sending the message after that 30 seconds. So let's define our task again. But before we define our task, let's see if you can retrieve the result. Yeah, seems not to be possible. So I'll define the task. Just a minute. Okay, so I want to clear this to have space. So let's define that again, and then let's now this time retrieve the result by this and disable the timeout. So I've given it an infinity option. So remember, this is written for 30 seconds for us to retrieve the result. And yeah, so it's working. So after the 30 seconds, we have been able to retrieve the result. So that means you have disabled the timeout. Okay, so with the Task.yield, you cannot pass the atom infinity. Then, before we go to the second difference, we wanted to show you that you can also increase the timeout so that you can retrieve. So if you don't want to disable the timeout for both, you can increase it. That is the similarity they both have. So I want to define our task again, because then call task.await, give it the task, and increase our time to maybe 35 seconds, at least to give it a 5 seconds time period to complete everything and to return the result back. Yeah, and it's working, so you can increase the timeout to retrieve that result. Then let's look at define the task again, then call task.yield, give it the task, give it also the 35. So first let's see what happens when you try to retrieve the result if it's not completed. It returns for you nil, but let's increase the timeout. The result is, so the second difference is that for the task.await, it causes an exception and crash if the task is still running, and we have seen this, but I can demonstrate again. But with the task.yield, it returns nil if the task is still running. So let's look at that difference. We already have our task to play around with. Let's define it again. So I'm defining it again because we cannot retrieve the result back once we have our result. Let's call task.await. I'm sorry for the dot that I'm calling each time. Yeah, it's exiting and also causes a crash. So it exits the reason. So here we have, it tells you that the default timeout is 5,000. Exit timeout, which makes sense because it's because of the timeout. So the task has not completed, so it has to crash. Define our task again, and this time call task.yield. Yeah, returns for you nil because the the process being the process that is running has not yet completed, so it returns for you nil. And let's look at the third difference. So with the task await, it can only be called once since it crashes if the task is not completed. But with the Task.yield, it can be called multiple times until the result is back. So let's look at that. So we define our task, and this time we're going to call the task.await like twice. So the first one, which we expected to crash, then the second one, and see what happens. Task.await, give it that task. So we expect a crash. Okay, then call it again. Call it another time. So that means after it crashes, you cannot expect a result that is done. Then with the Task.yield, define our task again. Now call Task.yield. Good. So I'll call Task.yield until we receive the result. But I think in an actual application that you're creating, this method won't be efficient. Okay, so you can see in the first attempt, we did not get the result. The second attempt, we also got nil. In the third attempt, we got the result back. Okay, so now I'm wondering what happens if we don't know the delay, how much delay it happens for us to send a message, and also how long should we increase our timeout in such scenarios, or how best to handle such cases. Okay, so that is something to think about. Okay, now let's go to we are in the fourth difference. So with the task.await, it returns the result once, and the subsequent calls will cause an exception and a crash. But with the task.yield, returns the result once, and the subsequent calls will return nil. So let's try that as well. So I'm going to define a task. Then with the task.await, I want it to return the result back, so I'll just give it an infinity. I'm disabling the timeout so as I can get the result back. So we are waiting here for 30 seconds. Now we have our result. I want to call it again and see what will happen. So I'm expecting a crash. Okay, it's forever waiting for the result, so I might need to close this and start the EX. So we have our task. So I want the task.await, give it the task and disable the timeout. Okay, we have our result back. So the next thing I want to do is call task.await, but I'm not disabling the timeout because it looks like it's waiting forever. Okay, we have a crash. Now let's demonstrate with the task.yield and see what happens. So I have the task. Now I want to call the task.yield, retrieve our result. So I will have to increase the timeout so that we retrieve the result. Okay, we've gotten a result back. Now what happens if I call the task.yield again? So with the task.await, I could not disable it for the second time because, as we have seen previously, it will wait forever for the result to be back. So I just wanted it to time out after 5 seconds if we can't get that result back. Or maybe I could better demonstrate it by increasing the timeout. Let's see that after the task.yield. Okay, so it's after the 35 seconds, it has returned for us a nil. That was expected. So I want to demonstrate the task.await again. So let's give the task await our task. This time I'm going to increase the timeout instead of disabling it. So wait for around 35 seconds for us to get the 30 seconds for us to get the result back. Okay, so we have retrieved our results. Now let's call await again. So we're waiting for 30 seconds. Okay, so after those 30 seconds, we have received a crash even though our timeout was 35 seconds. So this is because there's no result for it to return back. So the subsequent call, it's returning for us, and it's crashing instead of returning the result back because there's no result to be returned. Okay, so lastly, we have in case the task is stuck and never finishes, that is for the task await. It will stop the task as long the process timeout is not disabled. While with the task.yield, in case the task is stuck and never finishes, it will leave it running. Yeah, so one handles the shutdown, but one does not handle the shutdown. So that means with the yield, we have to manually shut it down. With the await, at least it handles it. So let's see how this works. Okay, so in here I had defined an endless loop, which we want to demonstrate with. So in this endless loop, the function endless loop takes in a number. So this is hard-coded number 1. So when it gets 1, we are going to call the endless loop again and give it 1 so that we have a forever running program. But if it's another number, we end the loop. So we are not going to end the loop in our case. So let's do this. So I'm going to define our task again because this time we're calling another function. So send message dot endless loop. I'll give it to number 1. Then end that task. So our task is running asynchronously. Now let's try to use the task await to retrieve that result. So there's no delay in our endless loop. So I expect after the 5 seconds for at least for the 5 seconds at least, to be a timeout or something. So let's call the task in here and see what happens. So remember task await has a default of 5 seconds, and here we are having an endless loop. So that's it. It has crashed because it cannot settle to because we're having an endless loop, an endless program that is running like forever. And that's what we had here. So in case the task is stuck and never finishes, it will stop the task as long the process timeout is not disabled. Then for the task.yield, let's see how that works. So I'll define our task again. Close this. then call the task yield and give it our task. So they both have a timeout of 5 seconds. So let's see what happens. Nil. Still nil. I'm going to call this yield 10 times. So this is 1, 2, 3, 4. So this is our 5th time. Our 6th time. 7th time. 8th time. 9th time. 8th time. 10th. 9th, sorry. Then last attempt of trying to retrieve the result. So this process is running like forever, and the task.yield keeps on running to try to, the task.yield will try to retrieve that result back instead of shutting it down. So that's it for today's series, and thank you for watching. Look out for the next one.